Hello and welcome to this video by DCSE Limited. My name is Dave Clayton. I'm the Senior Software Engineer for DCSE Limited, and today I'd like to take you through a walkthrough of our back-end services for our technology showcase for the Fantasy Formula 1 website. So just a quick bit of background. This website really is a sort of playground for us to learn new skills. Any new technology comes out that we like the look of, we can sort of try and implement into this system. But it's also a nice way to show our clients the sort of things we can do end to end, and the actual processes in place and the way we design our software. So here's the website here on the screen that you can see. It's a very bare bones system at the moment. It's still in development. There's a lot of work behind the scenes that you don't see, and that's what we're going to cover today. So the site at the moment really just allows you to log in. You can obviously register, sign up, all the sort of account management side of things. So we'll have a look at the services behind this. So the starting point, here's a sort of general architecture overview of what's in place at the moment. So the front end is written in Angular 9. So we've got this running as a Docker container on Kubernetes. So that then talks to a set of services on the back end. So we've got the user service, which handles registration, sign-in, the issuing of JWTs, all of that sort of stuff. So the user service communicates with a MySQL database, which is actually running in the cloud on DigitalOcean. And sort of gone for a microservice approach on this. So a good example of this working. So we've got RabbitMQ as a backplane here. So prime example here is that as a new user, go to the website and I register. That hits the user service, which of course then needs to send an email out, and that would have a link in the email for me to actually confirm my account. So the email is actually in a separate microservice. So we've got this email service here. So what happens is the user service does the registration, creates the data in the database, and then sticks a message onto the RabbitMQ message queue, which the email service is listening to that queue. It will then pick up that message and send out the email via SMTP server. In this case, we're using Office 365. So that's a generalized overview there. So if we start by looking at the user service component, so this is a .NET Core 3.2. Started out as .NET Core 2, but it's been upgraded along the way as new versions come out. So very small service, just doing user registration. So if I spin this up, you'll see we're using Swagger as an endpoint. Okay, so very basic. We've got account methods here, so register, confirm email, sign in, etc. And then we've got some user methods here. So once you're actually a registered user, you can actually get your user and update your details. So your profile image, your name, email, that sort of things. It's nice and simple. So I'm going to start top down. So we'll start with the controller. So if we take registration as an example. So controllers always keep nice and clean. So the only thing in here really is the Swagger data. And it's just, it's a post and it's a register method, and nothing else happens in here apart from we've basically abstracted the logic out into a controller service. So that will then call the register method on that controller service. So we have a look down into there, and then we find the register method. So here is our business logic of how the controller service works. So this really uses a lower down service called the security service to do the registration, and this is obviously just returning the result that comes back, or a 500, whatever actually happens based on the result of that register method. So if we drill down a bit further into the security service, so you then see our same register example. It returns a register result, which is an enum of statuses, takes in a register request, which will be username, email, all that sort of stuff. And here we're using identity framework to actually do the user management. So so checks on, make sure the email address is valid, name, etc. Make sure it's not a duplicate user, and then we basically set up an application user DTO, and we send that through and actually register using the user manager, which is part of identity framework. So that's kind of how that hangs together. In terms of retrieving data, so we've then got our database, so repository layer. So for example, on the user controller, you might want to get your user details. So we would have the user repository here that the user service would use. So then we've got the usual stuff with entity frameworks. This is it using EF Core. So find by username, it's just return by username. It's really simple stuff in here, to be fair. It's not anything technical. Update a user, the usual sorts of bits and pieces. So that's kind of how data is done and persistence. So a bit more about the sort of architecture of the service itself. So when this starts up, obviously we've got the startup class. So we go through and we're using app settings JSON. Don't have ones per environment because of the Kubernetes that we're using, which I'll explain in another video. So we don't really need that. This just contains local development settings. So first thing we do is obviously load up our configuration data out of the app settings and put that into the various models that we need. Obviously token management for JWT, MySQL availability for the health checks, and some metadata for the APIs such as version numbers, etc. And we just configure all the things like authentication, identity, all the usual stuff, database context, register queue comment. That's an interesting one which I'll come back to. So that's actually a NuGet component that's been linked in. It's a custom component that's built on Azure DevOps and referenced here. So this is just initiating the composition of that component and its dependencies via a method from that component. So I'll cover that shortly. RabbitMQ, configuring some bits and pieces for that. And then we've got some health check details here. So the dependencies we've got are RabbitMQ and MySQL. So MySQL is an out-of-the-box health check, whereas RabbitMQ is a custom written one. And just to demonstrate that working, so obviously the service span up previously as we saw. I've got some Docker containers running locally, so I've got MySQL running in a Docker container, and I've also got RabbitMQ running in a Docker container. So if I was to stop the MySQL container and then try and launch the service, what we should see in the console is it should be attempting to connect to MySQL and failing. So here we go, and I just used poly to try exponentially to 4 seconds. This is really for Kubernetes benefit, which we'll cover on another video. But if I start up MySQL again, you should see that this will then suddenly spin into life and carry on. So that's purely for Kubernetes purposes, but just shows the health checks working there. So now I'd like to talk a little bit about testing. I could talk all day about testing. Testing is vitally important. So the approach we take to testing our components is most things will be covered by unit tests. Some parts of the system will be covered by integration tests. So example of unit test, if we take the security service and the register method. So I've got a good blog post on my site about the given when then syntax. This is actually a custom implementation of given when then that I've implemented. It's quite nice. Feel free to read the blog, but effectively what we can do is our tests are sort of clear and concise. So you can see here, given an instance of the security service and I don't pass an email address, when I make a call to register, I should receive an invalid parameters response. So nice clear tests, and then we also get IntelliSense here, so we can step into that step to see what it's doing. It's fully async as well to deal with async method calls. So I'm not going to talk too much about that here, but just to sort of re-emphasize that pretty much everything will be covered by unit tests. But what we also like to do is integration test. So Web API on .NET Core provides us the ability to run our API and our endpoint in memory. And so what we can do is actually spin up an instance of this running against a database and actually hit an endpoint and make sure something ends up in the database. So what we do is effectively we use a test server, which is what Microsoft gives us for doing this. And what you can do is you basically point it at your startup file, so you're guaranteed you're running your actual endpoint. Now, if you're paying attention, obviously you see I've got test startup here, so I'm not using my actual startup file, but what I'm doing here is implementing my startup file. And really what I'm doing that for is I want to override particular methods. So for testing purposes, I don't want to use RabbitMQ, I don't want to test that. So what I've done is I've got a dummy sort of message sender here that I use DI to register. And what that allows me to do is effectively what it does, it writes the message to a file, so I can then pull out things like the code. So in a test later on, I can use the activation code and actually activate an account, so that sort of stuff. But it really is just using the base startup file. So yeah, once you spin this stuff up, you then get an in-memory copy of your API, which you can hit via a HTTP endpoint. And obviously, I'm using a MySQL instance. If you're on Windows, you can actually do this in memory. So there's an in-memory connection string there, which will use your entity framework migrations to actually build an in-memory database. So you can have an in-memory API and an in-memory database, run stuff against that, and when the tests are finished, everything's gone. Really, really nice, really fast. So some of the integration test examples here. So database, obviously, again, it's entity framework, so we can just do some simple checks on schema. Again, there's not a lot in this database, there's not a lot of tests around that, but basically I'm just checking the field length here. So if I pass in a correctly defined name and I save, it should get persisted to the database. If I do an incorrectly defined name, which is too many characters, then it should not be saved to the database. So that's what that test does. And then some sort of really funky stuff is the endpoint specs. So if we have a look here, an example of registering. So this will actually spin up the in-memory API. And like I said, because I'm on Mac here at the moment, I can't use the in-memory database stuff, that's Windows only. So I'm just using a MySQL database on my cluster in the cloud. But what I'm doing here is basically, if I've got an invalid email address, but I've got a valid name, valid password, I construct call to the register method. And when I call to register, I should get 400 back. So we can actually validate that endpoint is doing what it should. In the same way, if we had a completely valid request, the user should actually end up being created in the database. So this will actually go and check whatever database is connected and make sure that hitting the endpoint with the valid details creates the database. So it's fully integration testing that component all the way down to the database level, which is really nice. Gives you good coverage as well because you're covering the whole thing. So just an example of why I'm a big advocate of this way of testing. If we were to actually run all the tests in this project, you'll see it's probably about 5-second delay while it spins everything up. You'll see the unit tests, there's 99 of them, they complete almost instantaneously as you expect, but the 37 tests here in integration, once it's spun stuff up, they're just really quick. So they went through very quick there once it had actually done its setup. So we said, probably 15 seconds there end to end to 136 tests, and the coverage on that is very high, which I'll show you shortly. So yeah, really powerful stuff using .NET Core. So in terms of building this and actually deploying this somewhere, we're using Azure DevOps, and if I show you that, so what we've got is our pipelines defined, and the pipeline definition is actually a YAML file. So if I look at the sort of solution folder here in my Git repo, in my user service, I actually have an Azure Pipelines YAML file, and this is basically my build process for that component. So everything for this component lives in this folder, including its Helm chart for Kubernetes, Docker file, all of that stuff. So it's nice because you can keep everything together in one place. So if I wanted to change the build, I just do it on this file here, and it would automatically trigger build on Azure Pipelines. I'll probably do a separate video about this another time. So we can see that pipeline here. So here's the user service pipeline. If we just look at the most recent run, you can see here the different steps it's doing. So it's building it, testing it. So it ran all the tests in 36 seconds there. Look, that was the full end-to-end. I then published the test results and code coverage, and then basically build the Docker image and push it to, I'm using Azure Container Registry. Reason being is Azure Container Registry lets you publish Helm charts to that registry as well, and you can store them there as a repo. So everything here will all get tagged with the build number, so in this case 1026. So what will happen is we will get a Docker image tagged with 1026, we'll get a Helm chart tagged with 1026, and that can then effectively, once it's built, that's there, done, ready to be deployed. So my pipeline actually then, I've got a release which is triggered, so when a build completes successfully, the release for the user service would then build automatically. And in this case, I automatically deploy to a CI environment. I run some smoke tests, which are Selenium-based end-to-end tests. Really, really quick, simple smoke tests just to test that this component is working. So in my user server example, it will try and register a user and then make sure I use it in the database. Same sort of thing as the integration test is doing, but on a deployed level. If those smoke tests are successful, it automatically then progresses this into the UAT environment. Obviously later we'll be getting to staging and production environments, but we're not just there yet. So that's probably a good point to show you Kubernetes. So if I just get the pods on my cluster, so clusters again running on DigitalOcean, I'll get all the namespaces. So you can see here my CI environment, we've got 5 pods, so we've got my email service, RabbitMQ, SMTP, user service and web, so that's there running in CI, and that's where it automatically deploys to, runs the smoke test, and if everything's good it then runs to the UAT environment, which is just a different namespace. And obviously we're using Nginx ingress and things like that, which I won't cover in this video. But yeah, effectively what we have is one cluster managing several environments. So this is my UAT environment, and if I was to go to my CI environment, you won't see any difference because you can't see my title bar here, but this is another deployment, so you have independent sites running on the same cluster. Now I mentioned dev dependencies, so one thing, so identified obviously microservices, we don't want to be sharing code anywhere, everything should be self-contained. So QCommon is one of the libraries I've created for handling the RabbitMQ shared code. So service composition was what I was referring to earlier. So if we look in the startup for the user service, you'll see it's calling register QCommon, passing in the configuration collection. So what that does is actually calls the compiled version of the NuGet, which what this is doing is then doing all of its dependency injection, dependency registration, and setting everything up here. And then this is just a code library for being reused, so completely generic. So we've got the RabbitMQ connection factory. I think we've got our message handlers in here. So base message handler, which everything implements from, message receiver. So it's all the skeleton stuff that we're going to need in each of our services. So yeah, this is the shared code, if you like, but it's completely uncoupled from everything. It's loose. So what we do with this is then, again, using Azure pipelines, is when I commit code into that QCommon project, you'll see somewhere in here we've got QCommon, which again just goes through its build pipeline, done in exactly the same way, runs any tests that are in there, and then we just NuGet pack and push this. And the nice thing about Azure DevOps is we've got artifacts here built in. So if we look at artifacts, QCommon, so you can see I've got a few things here. So my test framework stuff, some utility classes, anything that we kind of are going to reuse. So QCommon is there. We can see it gets tagged with the version from the build, and then obviously we can reference that in our project. So if we were to look at the user service and look at our NuGet, we should see when it wakes up QCommon, and in fact we're out of date alert, so we've got an update pending there, but I won't go through that now. So I hope that's been useful, just a short brief introduction to the backend services of this project. Stay tuned for more videos to come.